Chapter 6, Trigonometry, Lesson 4, Proving Trigonometric Identities. Now, you have already met this concept in your Year 1 study of trigonometry, where you used the basic identities that you had covered to prove new identities and to learn how to construct a trigonometric proof. We are now going to take this further based on the additional knowledge we now have of some new identities. So let's refresh our memory of the identities that we have so far. Sine theta divided by cos theta is tan theta. Sine squared theta plus cos squared theta is 1. And then the other Pythagorean identities which follow from that, which you derived a few lessons ago. Tan squared theta plus 1 is sec squared theta, and 1 plus cot squared theta is cosec squared theta. Now, these may be provided to you in exams, but you still need to know that they exist, and you still need to know what they are. It is always evident that people are much quicker and much more efficient when forming trigonometric proofs and when solving trigonometric equations when they have memorised these identities off by heart. It makes it much easier to access them because you have them at your fingertips rather than wasting time looking them up. If you can memorise them, you are best off memorising them. So one of the key things in a trigonometric proof is showing step-by-step logic. So let's take a look at an example. We are going to prove that tan x over sine x is equivalent to sec x. Now, golden rule, you start with one side and you manipulate and simplify one side until it turns into the other side. You never ever start with both sides and start rearranging both sides or fiddling with one side and then the other side. Pick a side. Usually it's much easier to start with the more complex side and break it down to show that it can be rewritten as the other side. So I'm going to start with the left-hand side. So the left-hand side is tan x over sine x. Now, it will probably be easier to actually write that as tan x multiplied by 1 over sine x, separating out the division. As you can see, I'm going nowhere near the right-hand side of the original green line. I'm simply manipulating the left-hand side. So tan x I can rewrite as sine x over cos x. And then when I actually multiply by 1 over sine x, hopefully you can all see we have a cancellation here and here, and we're left with 1 over cos x, which is the same as sec x, which of course is the right-hand side. So there my proof is complete. And if you like, you can write QED at the end, or draw in the little square, which means you've come to the end of your proof. Now, a few things. Look at the structure of my working here. I only manipulated one side of the original question. I didn't manipulate both sides at the same time. I took one side and I showed that it could be rewritten as the other side using facts that I already have in my repertoire of knowledge. It would have been extremely wrong to start off with by multiplying both sides by sine x at the start. That's not a good way of going about this. Start with one side and manipulate it until you show it can be written as the other side. Example 2. Prove that tan x plus cot x is equivalent to sec x cosec x. Now, both sides here look quite complex. I've still got to pick one side to work with. I'm going to pick the left-hand side here. So I'm going to pick tan x plus cot x. Sometimes it's possible to actually start with either side because they're both so complex that it doesn't really matter which one you start with. Now, if you start to go very wrong and you can't see the end in sight, it may be the case that you've picked badly at the beginning, so go back. You should never really have more than about half a page of working at most when proving one of these identities. So tan x plus cot x, well, looking at my final answer, that I've got to reach on the right-hand side, it's all to do with sec and cosec, which is 1 over cos and 1 over sine. So I'm going to rewrite tan x as sine x over cos x, and I'm going to rewrite cot as cos x over sine x. Remember, cot is 1 over tan, so it will be cos over sine. Now, I'm going to take this and I'm going to give this a common denominator. So I get sine squared x plus cos squared x all over cos x multiplied by sine x. Now, what do we know about sine squared x plus cos squared x here in the numerator? It's 1. Okay, that's why it's really important to have these identities at hand when you're working through trigonometric proof. And the denominator simply stays as cos x sine x, but I can separate out the two parts here into 1 over cos x multiplied by 1 over sine x, and then I have my sec x cosec x, which is of course the right hand side, and there's the end of my proof here. So another top tip: always have the end in sight. Know what you are aiming for at the end of your proof so you can see where you are heading. And again, look at this. I picked a side and I worked with that one side until I could prove and manipulate it and show that it could be rewritten as the other side. So sec squared theta plus cosec squared theta, we have got to prove that this is equivalent to sec squared theta multiplied by cosec squared theta. Now, a top tip: it's a lot easier to deal with terms that have been added together than terms that have been multiplied together. It's very difficult, if something is a product, it's very difficult to split it up into separate parts, whereas it's much easier to start with something that's a sum and manipulate it so that you add these parts together. So the left-hand side is sec squared theta plus cosec squared theta. Well, what is sec squared theta? It's 1 over cos squared theta. And what is cosec squared theta? It's 1 over sine squared theta. So I have a pair of algebraic fractions. Common denominator, that's what we need to add them together. So effectively, I'm going to do the sort of the concept of cross multiplication here. So that would give me sine squared theta plus cos squared theta all over the product of cos squared theta sine squared theta. Eagle-eyed amongst you may have noticed a small mistake here where I've written an x there instead of a theta. I'm going to change that, go back, rewrite a bit of history there. Now, sine squared theta plus cos squared theta in the numerator, we know that's 1, and then here's our denominator. And then look at the answer that you're trying to get to over here again. And you can see that we are there, we just need to separate out the denominator into its two constituent products like this, and then this gives us sec squared theta cosec squared theta, and there's the end of our proof. This is the right hand side. So we're done in just a few lines of working here, but very difficult to do that working if you don't understand the trigonometry behind this. This takes practice. It is sometimes a topic that people do find more difficult, and that is why you must practice harder at it and make sure you follow the way in which I've structured my working here. Now, example 4 is a really interesting one. Prove that tan x sine x plus cos x is equivalent to sec x, which of course we know is 1 over cos x. Now, I would never ever start with the right hand side here. It's just so simple that it's very difficult to start with sec x and start with something so simple and almost build it up or add things to it. It's very, very difficult to do that, if not impossible. Now, starting with the left hand side here is much, much simpler. So tan x sine x plus cos x, let's work with that. So tan x, I'm going to rewrite tan x as sine x over cos x. The final answer that we're aiming for is all to do with cos. There's no tan involved, so let's remove tan from the picture by rewriting it as sine over cos, multiplied by sine x, and then plus cos x. So we've got sine squared x over cos x plus cos x, and I'm going to give these a common denominator. If I want, I could write cos x as cos x over 1, which perhaps helps with identifying the common denominator. So this is going to be sine squared x plus, and then this is going to effectively need to multiply here to give me cos squared x, and then it's all over cos x. You need to be able to find common denominators like that very quickly and very easily. Look at the numerator, sine squared x plus cos squared x. We know that's equivalent to 1 over cos x, and of course, what is 1 over cos x? It's sec x, the right-hand side. So again, we have come to the end of our proof. So pick one side to work with, pick the more complex side to work with, and break it down. Always have an eye on the target at the end so you know what to do. And you must know these identities really well so that you can make use of them in your proof. Look at my working. I'm going down the page. Those of you who work across the page in horrendous lines with multiple equals signs on them, that is poor notation. It is a very, very unclear way of expressing your work. Mathematical proofs should be line by line working down the page. Right, one last example. Prove that sine squared x is equivalent to tan squared x over tan squared x plus 1. Now, this is a case in point that we don't always start with the left-hand side. Here, the right-hand side is much more complex, and I would much prefer to break down the right-hand side than I would to do anything starting with the left-hand side. So I'm starting with this. Now, tan squared x in the numerator I'll leave alone, but the denominator, tan squared x plus 1, what do we know about that? It's sec squared x. So I have this. Now, my final answer is all to do with sine. So let's rewrite the terms we have. The numerator here, I have tan squared x, which is sine squared x over cos squared x, and I'm dividing that by sec squared x. But let's rewrite this sec squared x. What is sec squared x? Well, I'm dividing by 1 over cos squared x. That's what sec squared x is the same as. Now, division of a fraction by a fraction. We want to take the reciprocal, so we have this of the second fraction, and then multiply rather than divide, at which point you can see cos squared x and cos squared x cancel, leaving you with just sine squared x as the final answer, which is the left-hand side. So there we come to the end of our proof, and demonstrating that it's not always the left-hand side that is simplest. So just a few final words on trig identity proofs. There are a number of standard trig identities which you have to learn. Sine theta over cos theta is tan theta, sine squared theta plus cos squared theta is 1, 1 plus tan squared theta is sec squared theta, and cot squared theta plus 1 is cosec squared theta. There are others as well which you will learn in chapter 8 of trigonometry, but for the moment this is what we know so far. Make sure you obey the following rules when you're completing a proof of another sort of trig identity. So start with the more complex side and manipulate or break it down to show it can be written as the other side. Pick a side. Might be the left, might be the right. Start with the more complex side. If they both look extremely complex, it's usually easier to start with something that involves addition of two terms rather than something that involves multiplication or a product. Never manipulate both sides simultaneously. You start with one side and you manipulate it and show it can be written as the other side. You shouldn't be working on both sides at the same time. If it's not working out with your starting point, scrap it completely and try again, starting with the other side. Work down the page, not across. Working which is done across a page looks horrendous and unclear. All mathematics should be done line by line, working down a page for clarity using the structure I've shown you in the 5 examples today. Know your standard trig identity results. I've just mentioned the 4 that you really need to know. There will be others. It doesn't matter that they're in the formula booklet or that you can write them down on a piece of paper. If you have them memorised, you will be much quicker than other people at being able to spot when you need to use them and what they are. Link things. So for instance, you know that tan and sec are now linked via the identity 1 plus tan squared x equals sec squared x. Have that in mind. And also, as you're working through with one side of the identity, always keep your eye on the other side of the identity as well, so you know the target, you know what you are aiming to get to.